What is quantum computing? Quantum computing is computing by using quantum mechanics. So we use the field of quantum mechanics on top of normal computing to make quantum computing to allow us to do many, many more things. Quantum information. Quantum information is stored using quantum bits, or qubits. Like a normal bit, it represents a position of 1 or 0, but is also a quantum system, like an electron or a photon. This allows the qubits to do many different things to separate them from normal bits. So they can be in a state of superposition, they can be subject to quantum interference, and can be entangled with other qubits or be in quantum entanglement. These factors let quantum computing in some cases be much stronger than normal computing. For example, like cracking a password. With normal computing, it would take ages to break some passwords going through every single different option. But with quantum computing, you can do all of it at once and it can happen in seconds. This is those specific situations that can make quantum computing so much better than normal computing. Quantum interference. In the quantum realm, particles act like waves, sometimes. And when those waves line up, they amplify each other, and this is what we call constructive interference. When the waves oppose each other, they cancel out and nullify the wave, so that's called destructive interference. We can use this in quantum computing to skew results to be more desirable. We can use quantum gates that we can control the waves of to use constructive interference to amplify the chance of getting one result and destructive interference to lower the chances of getting another result. So if there's a desirable result that we wanted and the chances of getting it were lower with the quantum bits, we could add these quantum gates to increase the chances of getting the correct answer and lower the chances of getting the wrong answer, using constructive interference to amplify the right answer and destructive interference to eliminate the wrong answer. Big contributors to the quantum computing field. The big contributors to the quantum computing field include large companies doing research, mainly tech companies like IBM and Microsoft, and also very prestigious and large universities like Harvard and Berkeley.
Quantum superposition. What is it? Well, to begin, it's a fundamental piece of quantum mechanics as a whole. Essentially, superposition is the ability for a quantum system to be in several states all at the same time until it is measured. However, superposition cannot be observed directly by the eye. You're only able to measure the results of it, and its interference. Qubits use this to be in a state of both 1 and 0 at the same time, being a proportion of 1 or 0. When measured, these always become a full 1 or 0. So when you have more than one qubit, let's say 2 for example, or when you have 2 normal bits, the outcomes can be 0, 0, 1, 0, 0, 1, and 1, 1. 2 qubits can be all of those outcomes at the same time, not just one of them. Schrödinger's equation. Just as a small explanation, a reprise if you would, Schrödinger's equation, not to be confused with Schrödinger's cat, is essentially the quantum version of Newton's second law, which is force over mass of an object gives acceleration. Quantum entanglement. So, quantum entanglement is when two particles are generated so very close together that neither one of them can be individually identified as independent. They essentially become one. Additionally, I must add that this is not present in classical mechanics, only quantum mechanics.